Hey, my name is Dave Mango. Dave Mango on Twitter. Really hard to figure that one out. Today we're going to talk about familiar smells I've detected in your systems engineering organization and how to fix them. And so I've talked to a couple of people out in the hall and they're like, oh, like code smells. Yeah, like code smells, but these are systems engineering smells. So real quick, I have more than 20 years experience in systems engineering. I've worked at big companies like Cable and Wireless and Salesforce, small companies like Terracotta and Tag, and I've led DevOps transformations and systems engineering transformations at these companies. What this has allowed me to do is get lots of material to entertain you about things that I've seen people do over the years at different places. I consider myself an international DevOps contributor. You'll probably hear a little bit of that passion in the presentation today, but given talks about DevOps in lots of places. I was here in Nashville like a few years ago at the Agile conference. And because of stuff like that, I've written a video course called Mastering DevOps you can get from Pack Publishing. I've contributed to a couple of books. Most recently, the Seeking SRE book that was talked about in the keynote this morning that came out last month. I have a little blurb in there about the overlap between SRE and DevOps. So smells, like why am I calling them smells, right? Well, we know one thing about smell, about our olfactory system, it's one of the strongest neurochemical things that we have, right? When we smell something, it can bring back emotion from 20 years ago. It's a really powerful thing. And so a lot of times when I go to work with a new group or a new team, there's certain smells that just come out that are really kind of strong. And those are things that I recognize as patterns, right? Humans are really good at pattern recognition. So we're going to talk about some of those smells today. And we're going to talk about them in terms of failures a lot, right? And that's okay, right? Because we learn more from failures. But if you see these smells or you smell these smells or whatever you want to call it in your organization, like don't take this as a criticism. Like this isn't to say that, you're doing it all wrong or anything like that, because part of what we're going to talk about is how to get out of the situation, how to put these kinds of things behind us. And so as a result, it could be kind of an opinionated talk, right? I might say things like, hey, you should do this, or you shouldn't do this, or this is really bad. And that's okay. Like, take kind of whatever lessons you can and apply them in whatever way works well for your organization. There's no way that I can sit up here and give some blanket, this is how it's going to work for you. So with that, that darn pager. Has anyone here ever been on call? Is anyone here on call right now? Okay, you have to leave early, that's all good. So yeah, carrying a pager is part of our responsibility as systems engineers. That's where we are right now. Maybe it won't be like that forever, but that's where we are. And I've worked in lots of different organizations that have different kinds of pager load, let's call it. So I've worked with, places that you get paged like 3 times, 4 times a week, right? That's pretty normal. I've worked at places that getting paged is so infrequent to that level. Has anyone else ever done this? You go and you check the monitoring system to make sure that it's still working because I haven't gotten paged in a whole bunch of days. And what's going on? Like, how could that possibly be? But I was sitting at Monitorama, which is a great conference, a few years ago, and there was a bunch of people who were going up and giving talks about their paging and how they were getting paged. And they were talking about getting paged like 40 times, 50 times in a week. And I was like, that's like an order of magnitude larger than anything that I really am accustomed to kind of working with. And I looked at my friend Mike next to me. I'm like, is this for real? And so, that's kind of a problem, right? 40 or 50 times in a week. And then I've worked with other companies where they were getting paged 90 times in 6 hours. "90 times in 6 hours." And why am I saying it like in terms of 6 hours? I'll get to that in a few slides, why we're doing it in 6-hour increments instead of how many times in a week, right? But we know getting paged is really bad. It's bad for your family. It's bad for your social life. It's bad for all kinds of things, right? We don't want people to burn out. We don't want people to leave the company. Like Brandon talks about, like Netflix is like, hey, you want to work somewhere else? That's cool with us. Like if I'm getting paid 90 times in 6 hours, I want to go work somewhere else. Like there's no question. This is like really bad for retention and things like that. And who knows why I'm getting paged? Is it because I have bad signal to noise ratio? Is it because I'm not getting actionable alerts? Like I certainly do not want to get something on my phone that's not actionable at 3 o'clock in the morning. That's ridiculous. Like I don't mind if you notify me about stuff, stick it in a Slack channel, send me an email, whatever. Do not put something on my phone unless it's an actionable alert. And so people try to get out of this by doing like some pretty crazy stuff, right? They try to do outsourced operations. Has anyone ever seen anything like this? This company that was getting paid 90 times in 6 hours would break up their on-call shift into 6-hour shifts so that nobody would have to spend 24 hours getting paged like crazy. And the overnight shift at midnight would be outsourced to some operations team on the other side of the world. Why? So they could sleep, right? I can't get any sleep if I'm getting paid 90 times in 6 hours, so I'm going to outsource my stuff to the other side of the world. Not really solving the problem, right? And so I worked at another company that was outsourcing ops, like this is the smell, right? This outsource ops, because they were going to have all their level 1 pages go to this outsourced ops team on the other side of the world, and they were going to get the level 2s and the level 3s because they were important and doing like the real high, the real important work, right? So what was this team on the other side of the world doing? They were deleting logs off of disk. And I was like, well, why don't you just write a script to delete the logs off the disk? What do you need a team for that for? Well, we have a script, but it doesn't delete enough stuff. So we need to have humans go through. I'm like, well, why don't we fix the script? Well, this is just temporary. Like we're just going to have, until we can get to the point where we're going to, fix the disk, then, we'll just have them do it, right? The road to hell is paved with short-term projects that never died. How many people think that they had this outsourced ops company for a month? How many think it was 6 months? How many think it was multiple years? Yeah, if I'm not feeling the pain, forget it. I'm not going to fix that. There's 100 other projects I could be working on. Their incentives are completely wrong. Their incentives are in the wrong place. If they're feeling the pain, I guarantee you they would have found someone to fix that script. And they get into these weird situations, right? Does anyone know what city this is? There you go, Stockholm, Sweden. I used to run the SRE team for Pingdom, so this city has a lot of dear things in my heart. But people get into this like Stockholm Syndrome with their infrastructure. They're like, oh, well, it's supposed to be like this. It's not the infrastructure's fault. I guess I can identify with it. Like, they can't fix it anymore because they think that their job is to run around and do this, in SRE we'll call it toil, right? To run around and reboot the Tomcat server. Oh, the Tomcat server's stuck. Let's reboot it. The Tomcat server's stuck. Let's reboot it. We do this every day, right? That's not okay. We should not be running around rebooting Tomcat servers because our pager goes off. And they get to the point where they think this is normal. And so here's a quote from the company that did the 90 times in 6 hours. We don't have fires. We get new customers. They have a bad experience. They leave. That's just how it works. Because they're starting to identify with their infrastructure, right? This is how it's supposed to be. Like, this is my job, is to reboot stuff. And my answer to that is really like, just because it's always been broken doesn't mean we shouldn't solve it. Like, just because we're in this situation, we need to be able to get out of it. So what I always advocate is let's not fix problems, let's solve problems. Rebooting a Tomcat server, and I love Tomcat, used it for years, not busting on Tomcat. Rebooting a Tomcat server every 3 days is not fixing the problem, or it's not solving the problem. It's just fixing the problem. It's making the problem go away. Why is the Tomcat server need to be rebooted? Is it running out of memory? Is there a file descriptor leak? What is it that's causing this problem? For my SRE teams, I never want people to do the same remediation twice. That's a terrible, terrible thing. We're humans, we're smart, we should be getting ourselves out of these situations. So how do we do that? My favorite way of doing this, crawl, walk, run. right? We're going to talk about this a few times in the talk. But we can't jump to the end. We can't get to the magic place where we're Netflix and we have chaos monkeys and all these other things. Or we can't say, hey, we're going to run Kubernetes tomorrow in production. Sounds great. We've never done that before, but Kubernetes is cool. Everyone else is using it, right? We need to crawl, walk, run. This is like Eric Ries. People have read The Lean Startup, right? He talks about the MVP, the minimum viable product. Like, that's the smallest thing that we can do that we can learn something from, right? So what's the smallest thing we can do? Crawl. So this is, people might have trouble seeing it, but this is like an example of the PagerDuty API, where you can actually go to PagerDuty, and I'm sure OpsGenie and all the other ones have this too. You can get a list of all your incidents inside some time period. So go to PagerDuty, write that, whatever, it's like 16 lines of Python or something like that, and get a list of what the things are that are blowing up in your infrastructure over some time period, and bring that to your stand-up every day. Hopefully people are doing some kind of agile process at their work, and say like, hey, we got paged 14 times for the Cassandra nodes, we got paged 12 times for this Tomcat service, service X, whatever. What are we going to do about this, right? We have to get ourselves out from underneath this rock. We have to get ourselves away from this Stockholm Syndrome with our infrastructure. And once we've kind of be able to get a little bit of triage like that, for like the medical term, then we can look at more structural things. This would be our walk, right? People familiar with Conway's Law? Conway's Law is the communication patterns of your application will resemble the communication patterns of your organization. Right? There are structural elements here at play as to why we're in this situation where our pager's going off like crazy. If I have a VP of architecture, a VP of operations, and a VP of engineering, they're all separate. Are our incentives aligned? I have no idea. Like, maybe they are, maybe they're not. Maybe the engineering people are trying to put out features and the operations people are trying to put out fires or, keep the infrastructure running. Like, if I was going to look at this org chart, I would say take the architecture and the operations VP, move them under the engineering VP, who I guess now is an SVP. Congratulations, you got a promotion. But at least everyone's going to be, under the same incentives and under the same alignment, right? We have to be able to have the developers care that the operations people are being woken up at 3 a.m. or maybe they get woken up at 3 a.m. or whatever. When you're ready to run, then you can go to something like follow the sun. But do not even think about doing anything like this unless you have your incentives aligned. Unless you have already embraced like MTTR, and I know Allspa doesn't like the M in there anymore, but unless you really care about your time to recovery, your time to remediation, unless you have things like SLOs, service level objectives, that are global, that everybody across all the teams understands like what we're going to do here, and what kind of things, objectives we're trying to achieve, don't think of doing something like this. Why? Because otherwise all you're going to do is kick the can down the road, right? If it's 11:30 at night and I get paged and I know that somebody else is going to be taking over the pager at midnight rather, on the other side of the world probably, and I've got 45 minutes of rebooting Tomcat servers, am I going to wait for 30 minutes, or am I going to spend 45 minutes rebooting? No way. I'm just going to, it's someone else's problem in less time than it's going to take me to remediate. So we have to have our incentives aligned. Otherwise, we're never going to get out of this situation. And we have to make sure that we have all these things in place.
I got so much trouble in my mind. I got so much trouble in my mind. I got so much trouble in my mind. I got so much trouble in my mind.
Untested infrastructure. Oh man, it's actually kind of cool listening to the Uber talk right before this, where a little bit this stuff kind of overlaps. But like we, as an industry are still moving out of some of this stuff, and we should never be deploying changes to production that have not been tested. So I really do not like the smell of runbooks. And when I'm saying runbooks, I don't mean like remediation runbooks where it's like I get an alert, it's like you could look at these graphs, these are ways of resetting stuff, whatever. I'm talking about procedural runbooks. Procedural runbooks stink. Okay, I worked at a place where, and this is a smell you might recognize, where we had to go and, I don't know, for whatever reason they had it structured this way, I was on call, so I was involved in this maintenance that happened on a server. And they got on the server, and the Word doc or the Google doc or whatever it was that was telling the humans what to do for the computer, makes no sense, said, hey, you should be editing this file Etsy bar. Well, they looked around, and there was no file named Etsy bar. But somebody found a file in Etsy/foo/bar, so maybe we should edit that. Does anyone think that's a good idea? Well, they did it anyways, right? And then they went into the file in Etsy foo bar, and it says, well, we're supposed to edit this section. Well, we can't find a section that looks exactly like that, but we found one that's kind of close, so let's edit that. What could possibly go wrong? And then we try to like make this safe, right? Oh, we're going to make this safe. We're not going to have people just doing stuff willy-nilly on the servers. That checklist or that like Word doc that people are following, we're going to run that through change control, right? A bunch of humans that are going to review something, like that's going to fix everything. Do you really think that the humans who reviewed that change about Etsy bar said, hey, if you can't find Etsy bar, go ahead and edit Etsy foo bar? No, they never said that, but we did it anyways. And you can say like, well, they shouldn't have edited the file. Like, no, they should never have been put in a situation like that. And change control and cabs and all those things, I think, are an awful smell as well. I don't think that fixes anything. So how do we get out of this situation? Crawl, walk, run, right? Crawl. Unit test, infrastructure unit test, right? We can use RSpec, we can use Test Kitchen, ServerSpec. DOS is a pretty cool Golang version of some of that. But we have to make sure that the changes that we say that are going to go out to production are the ones that we expect to go out to production. This is whether you're using Puppet, Chef, Salt, whatever. But also if you're using containers, containers still need to be tested. There's nothing about a container that I'm going to build in Docker that says that the Etsy foo file or whatever is going to be there. That thing could just not exist. Immutable infrastructure is not going to save you from bugs. So we have to make sure that those things that are going out are stuff that's tested. We want tested infrastructure. Once we've done the crawling, we can get to walking. And if you ever worked with me, you've heard this phrase a million times. Stages like prod, stages like prod, stages like prod. I mean, so many situations where I walk into a place and I'm like, why is it done in this way in staging and it's done that way in production? You should never be asking that question. Like if it's a C4 4x large in production, use a C4 large in staging. I don't care, but don't be running like Postgres in staging and MariaDB in production. That makes no sense. And if people try to take these shortcuts. So if you have this as a mantra and someone's like, well, how should we do this in staging? That becomes a nonsensical question. Stages like prod, stages like prod, stages like prod. And you need to have these representative test environments where you can test stuff. Gene Kim talks about the ability to stand up representative test environments is one of the highest indicators of high-performing operations teams or IT teams or whatever you want to call it. So we need to be able to have stuff like this. And I know it's all the rage now that, hey, testing in production is the only way to go, like whatever. Like baloney, like check out, continuous delivery by Humble and Farley. Like we need to have environments where we can test stuff before they go to production. And then when we're running, then we can do all kinds of cool stuff in production, right? We can do dark launches. We can do feature flags. Feature flags is a great way of testing stuff in production. Let's just turn it on for 1% of users and see what happens, right? We can do canaries. We can do blue-green deployments where if something goes to heck, we can roll it back. And then, we can still use things like configuration management for our stateful tiers. But we don't want to get into production without stuff that's been tested, and we don't want to have a reliable way of testing it. It's just way too dangerous.
I got so much trouble in my mind. I got so much trouble in my mind. I got so much trouble in my mind. I got so much trouble in my mind.
Boring technology. Is this a good smell or a bad smell? Who thinks it's a good smell? Who thinks it's a bad smell? All right, well, I'm going to say that boring technology is really, really, really good. I love the smell of boring technology in the morning or something. Dan McKinley, he's McFunley on Twitter, says, we should generally pick the smallest set of tech that covers our problem domain and lets us get the job done. I don't like fancy solutions in my infrastructure, especially in production. I want to make sure that whatever solutions I choose are simple and boring because I want to be able to understand what they do. I do not need to introduce complexity. In distributed systems that we work in right now, complexity is an emergent property of the system. There is nothing we can do to avoid it. So introducing additional complexity where it's not necessary does not do anything for us. It just causes problems. And the problem is that incentivizes the wrong thing, right? These fancy things like RAID cards and SAN storage, how much redundancy do you need in SAN storage? Like they're incentivizing not having failures. Well, that's not really going to be a thing, right? If we're going to introduce complexity here, we're incentivizing MTBF. And I don't know how many people here have ever configured bonding on a Linux network interface. Anyone know how many modes are there for bonding? 6. Wow, someone pulled that right out. That's awesome. There are 6 different modes for bonding. There's like HA, there's failover, there's all kinds of weighted this and that, whatever. Well, what driver is that hooking into? And what's the failure behavior for that driver of that network card going into that brand of switch? Oh my God. Let's see if I can still do that. We can't stop failure from happening. We need to learn to tolerate failure. And putting fancy solutions in that are going to stop us from having any failures is not really going to work. And another smell associated with this, and I'm not going to bust out the blues harmonica for this one, is when things have changed in our environment, we need to embrace those things. If I've been using RAID cards and I walk into an organization that could be using like EBS volumes, and they're still like, no, we're going to do all this fancy stuff with our RAID cards, that's a problem. Right? We need to be able to embrace like the changes in technology that make the environment simpler. Simpler is better. Because if we are trying to embrace this idea of not having failure, we get, Nassim Taleb's Black Swans. And I'm pretty sure there's a talk this week about Black Swans. So you should check it out. But he said, this is Jez Humble summarizing it, but these artificially constrained systems become prone to black swans. Such environments eventually experience massive blow-ups, catching everybody off guard and undoing years of stability. I don't want to be in a situation where everybody's scrambling to try to understand what the hell just happened because we've never seen this before. We don't understand what just happened. We need to prioritize mean time to recover over mean time between failure, and we need simple solutions in order to be able to do that kind of thing. Aaron Blahoyak from Netflix says, so instead of trying to prevent errors, optimize for a relatively frequent occurrence of low-impact errors. For infrequently occurring errors, this means we need to induce them, right? From the Uber talk right before this, right? They're going to expect relatively frequent occurrence of low-impact errors. It's right there, right? Why did Uber choose that, right? They're adhering to these ideas. So how do we get ourselves out of the situation, and where do we want to go? So again, crawl, walk, run. First, you have to be able to configure all these fancy things or whatever, at least with code, right? So whether it's like Puppet types and providers or whatever, if I'm going to destroy something, I want to know that that thing's going to come back exactly the way that I expected it to. So if you're going to destroy something and you're going to go on there and hand configure your RAID card, forget it. Like you've lost already. Like you need to have these things configured the correct way. So I apologize if this picture is blurry, but I snapped it in the airport in Chicago, like 6 years ago or something like that. And we were testing these moonshot servers, wherever I was working at the time. And so this advertisement says, it's time to build a server for the next internet. God, that sounds awesome. The next internet? I want to do that. And so I was talking to the people who were testing it, and I was like, so what's the API look like for this thing? Like, how much functionality is there? Oh, there's no API. What? There's a CLI, like you can get on the console and configure it. Oh, really? The next internet is going to be configured by a bunch of sysadmins getting on a CLI and hand configuring crap. Like, no way. I'm sorry, that's not going to work. So we need to have a way of configuring this stuff like programmatically. When you're ready to get stuff into production and you're ready to do walk, do a production readiness game day. A game day is when we have a list of failures and we go and we induce those failures and then we see what happens. So test your services before they go to production. At least it will prevent you from launching something that's broken into production from the bat. Not only that, but if you're probably going to have to go through 2 or 3 of these before your stuff is ready to go to production, but the operations folks will get to test the remediations. They'll actually get practice testing remediations. They'll understand what they're supposed to be looking at and stuff like that. And once you have that practice with remediations, you're going to have a much lower MTTR, right? Your systems are going to evolve. We know that. We're going to be deploying code all the time, stuff like that. The remediations are not going to change as radically as your system. So at least as a first step while we're walking, we can do that. And lastly, when you're ready, move over into chaos engineering. Nora is speaking on Wednesday, so definitely go check that out. But Nora says, chaos engineering isn't done to cause problems, it's done to reveal them. Right? We know that we're going to be deploying code all the time. So these systems are going to change. The thing that I may have launched with, maybe the remediation is not the same. But if we can introduce these failures, like Aaron says and like Nora says, then we can actually do a really high mean time to repair, or really low mean time to repair, I guess. But this becomes a lot easier when we're working with simple systems, when we're working with boring technology. So things to take away. If we want to make changes, crawl, walk, run, stages like prod, stages like prod, stages like prod, and make sure you choose your incentives wisely. Thanks.
Do we have a couple of quick questions from anyone?
Excuse me. Could you clarify a little bit on your kind of negative comments on runbooks?
The problem I have with runbooks is generally like all those, if I can write it down in a Google Doc and explain step by step what can be done or what should be done, then I should be able to write a script for that. Like humans are really bad at doing boring repetitive tasks over and over again. Computers are awesome at doing boring repetitive tasks over and over again.
I really like your talk.
Thanks.
I have slight disagreement.
Great.
I don't think just because it's a good piece of software is necessarily boring. So the right solution isn't necessarily boring, in my opinion. In fact, some of the most interesting solutions are the ones that just work and are extremely simple and let me spend time at home.
I think that's boring. No, more simple, the more boring, I believe. So I think we're in agreement. And if you have smells that you've experienced, definitely like check me out in the hallway or whatever, or hit me up on Twitter because I would love to hear about them.
So you used the examples of like bonded NICs and RAID controllers as a way of hiding failures that we should not do. However, it's not hide. I mean, where do you draw the line between software like load balancers hiding failures from you and like the bonding driver or a RAID controller? They seem to all be trying to hide failures. So where do you draw the line? Which is a good failure to hide and which is a bad failure to hide?
That's a good question. So the problem I have with the fancy stuff like that is not about hiding failures at all. Like I think the load balancers are great. What the load balancers allow us to do is to keep on functioning and nobody knows the difference whether we have a failure or not because I'll just distribute the load somewhere else because the health check didn't pass from the load balancer, so I don't see that anymore. The problem is when we rely on the fancy stuff and then something goes to hell and we can't deal with that anymore because we never expected anything to go to hell. And that's where the problems occur.
So I still fail to see the distinction between how the load balancer isn't a fancy technology, but RAID is. I mean, where do you draw that?
So the load balancer would be a fancy technology if we were trying to rely on the load, like a single load balancer keeping itself up through like redundant power supplies. But if I'm going to do things like VRRP or HSRP or whatever incantation you would like of CARP is, then that would be kind of a different scenario where I'm able to tolerate a failure. I can go in and kill a load balancer and everything keeps working.
Yeah, my RAID controller allows me to kill the hard drive and it keeps working.
Yeah.
So.
Yeah, I would ask, I agree about the RAID. I mean, I have, RAID in place on my file server and replication going on between buildings so that if one of the two file servers dies for some reason, I can easily get my people back, up and running, or they instantly can get pointed over to a read-only copy of stuff. So when you're talking about reducing mean time to failure, I think there's some value in that because, I don't want to be running around putting out fires because stuff broke. So if you're going to value mean time to recovery, don't you need a way to automate some of those recovery mechanisms first before you throw away your mean time to failure?
So I guess what I would argue is most of those systems are built for HA, and the problem with HA systems is that when you lose one, now I have a single point of failure. So I would much rather distribute 3 copies of my Cassandra stuff over 3 availability zones on Amazon than have some HA situation where one of my things goes down and now I have to page somebody and get them on it because I have to get that other one back up because now I'm at a point where I'm at a single point of failure. And it tends to be cheaper to use the boring technology like just a disk, like an EBS volume, than to pay some fancy vendor to sell me some expensive thing where once I've lost that thing, then I've lost that thing, and what am I going to do? I remember talking to somebody about they wanted to do stuff in a data center, and I wanted to do it on Amazon. And they're like, hey, Dave, look, your solution is so expensive. Like, why is my solution expensive? Well, I can get the same server that you're going to get on Amazon. You're paying $38,000 for it. It only cost me $26,000 to get it from Dell. So data center is way better than cloud, obviously. I was like, great. What happens when your server dies? What do you mean? Well, I can just spin up another server on an API call. It'll be up in a few minutes. What are you going to do? Well, I got 24/7 support from Dell. I guess they can send out of the... No way, dude. Spend your $52,000 to get your redundant things. I'm spending $38,000. So I much prefer the simpler solutions. Thanks.